sequence, and we're asked to write a rule or an equation in order to find a sub n. So this is the first time that we've been introduced to the little a with the sub number. All that means is that's what term we're on. So a sub 1 is our first term, which in this case is 15. A sub 2 is our second term, which in this case is 21. And it follows that pattern all the way to a sub 42, which is our 42nd term, which is what we're trying to find. So the first thing that we want to do is figure out what type of sequence this is. To get from the number 15 to 21, I'm going to add 6. To get from 21 to 27, I'm going to add 6 again. From 27 to 33, I add 6. So this is an arithmetic sequence since I have a common difference and I'm adding the same number each time. So if we were to continue adding 6, we would get 39, 45, 51, and so on. Now to get this 42nd term, I could continue adding 6 until I get to the 42nd term, but that's going to take a minute. So what we want to do is write an equation in order to find that term. So think of an arithmetic sequence kind of like a linear function. With a linear function, we have mx plus b, where m is our slope and b is our y-intercept, or our initial value. Another way that we can think of initial value is our first term. So we can replace this b value with a plus 15 because we know what our first term is. We also know what our slope is. If you think about a table, when we have a linear function, the number that's being added to the y value each time is equivalent to our slope. So since I'm adding 6 each time, we can think of 6 kind of like our slope. So this is the equation that we have for now. Let's test it and see if it works. I want to find the 42nd term. That's my unknown. Let's plug it in for x. So I have 6 times 42 plus 15. This is going to simplify to 267. Now there's a couple things wrong with this equation. Okay, the first thing that I want to fix is just cosmetic. It's just fixing our variables. Okay, whenever we're talking about sequences, I don't want to think in terms of slope and y-intercept. I want to think in terms of common difference, which is going to be d. And I want to think in terms of initial value or first term instead of y-intercept, which is going to be a sub 1. Now the second thing that I want to fix is this right here is telling me that I'm adding the number 6 a total of 42 times, but is that really the case? So here between term 1 and term 2, I add 6. Between term 2 and term 3, I add 6, and so on. If you were to tally up the number of times you're adding 6, it's actually 41 times, which is 1 less than your final term because you're looking at the in between the terms. You're not counting up the number of terms, you're counting up the number of times you're adding that common difference. So the x is a little bit misleading. What we want to do is say whatever this term is, which remember is a sub n, is our unknown term. Let's use an n instead of an x, minus 1, because that's how many times we're adding that common difference. And then my a1 value, my first term, stays the same. So let's try this. So we know that this is wrong. This is not a good equation to use. Okay, so if I plug in my common difference, which we know is 6, the term that I'm looking for is 42, but remember I'm only adding that 6 41 times, so I'm going to subtract 1. And then my initial value or my first term is 15, that remains. So we have 6 times 41 times, plus 15. 6 times 41 is 246. And whenever we add that 15, we're going to get the number 261. So that's my 42nd term. And then if you'll notice, we also have our equation to find that 42nd term, which is right here. So if I wanted to find another term other than the 42nd term, all you would have to do is replace this 42 with whatever term you're trying to find. So if I want to find the 100th term, you'll replace this 42 with an 100, and don't forget your minus 1.